When you look at why Docker was created and why it's popular, it's mostly for its ability to reduce the amount of time that it takes to set up the environments where our applications run and are developed. Just look at how long it takes to set up an environment where you have a Java or a Spring API for backend which utilizes MariaDB or another database. And then if you add your applications or frontend, you may need to set up Node and NPM, and that's just the start. When your development team grows, you need to ensure that it has the same front-end and back-end resources in their local environments. Your testing team should also be on par with the correct environment. Docker gives you a guarantee that everyone will be working with the same resources. All of these scenarios play well into Docker's strengths, where its value comes from setting containers with specific settings, environments, and even versions of resources. Docker is great for the development of microservices. Nowadays, the microservice architecture is greatly utilized by absolutely everyone. Docker is super easy to install and run your resources. By automating the important part of the deployment lifecycle, you save a lot of time and also make the whole process easier for everybody. Now, let's go briefly over the main components. Docker is written in Go and takes advantage of various features of the Linux kernel, such as namespaces and cgroups. Docker uses namespaces to provide isolated workspace containers. When a container is run, Docker creates a set of namespaces for it, providing a layer of isolation. Each aspect of a container runs in a separate namespace, and its access is limited to that namespace. Cgroups are used to limit and isolate the resource usage, CPU, memory, disk I/O, network, etc., of a collection of processes. Cgroups allow Docker Engine to share the available hardware resources to containers and optionally enforce limits and constraints. A registry is the piece of software that holds Docker container images. It's where we place our image or get images from. There is a public Docker registry that's managed by Docker, Docker Hub. Later in the course we'll create a private registry of our own. An image is the resource that you need in order to start a container from. The image contains all the information that our container needs to build a container exactly the same way across all systems. Imagine you're running an Ubuntu virtual machine. In order to start an instance, you need an image. The same idea applies here. The image that you download or create is stored on your machine storage media. Your local instance of the image will be used if you decide so. Also, once you download the image and it's available on your hard drive, you won't be downloading the image again in the future. But that only applies if there are no changes to the original image you're pulling from the repository. A Docker file is a file that contains a predetermined set of instructions. It's used like a recipe to create Docker images. We'll learn how to make one after a few lessons. In order to use an image, you should create a container. A container is a running instance of your image. For example, you can have the Mongo database in one container, then the front-end Angular application, and finally your Spring or Tomcat server in a third container. You can have more than one container from the same image. There's no limit to that. However, the container should be named differently. Fundamentally, a container is nothing but a running process with some added encapsulation features applied to it in order to keep it isolated from the host and from the other containers. So why do we need containers? Aren't they the same just like an OS? A container runs natively on Linux and shares the kernel of the host machine with other containers. It runs a discrete process taking no more memory than any other executable, making it lightweight. By contrast, a virtual machine runs a full-blown guest operating system with virtual access to host resources through a hypervisor. In general, VMs incur a lot of overhead beyond what's being consumed by your application logic. You can also have volumes which persist and hold the data of your containers. If your applications are on containers which are static and unchanging, the data that changes is on the volumes. So imagine volumes are like hard drives for your application. Finally, we have networking. By default, if the containers have no defined networking, they cannot speak with one another as their scope is isolated. Unless we set up networking between containers, they will not be able to be in connection.